Hey, welcome back. Solving logarithmic equations. So in this video, we will go over a few examples where you're solving logarithmic equations. So the logarithmic equation simply means that a statement, the initial statement that is given, has to have a logarithm in it. So the first one, question A. Log to base 2 of x minus 4 is equal to 4. By just recalling the relationship between logs and exponents. So log to base a of b is equal to c because a to c is equal b. So just by converting this into exponent, you can go 2 to exponent 4 is equal, it's written a little bit differently than I indicated here, but the idea is exactly the same. So the base 2 to exponent 4 is equal to the value inside. Then by just manipulating that linear equation, 2 to 4 is 16, adding, there you go, solution. Part B, log to base 10. Recall that when I have a log and nothing for the base is there, so that simply means that this missing base is always 10. So this is why when you resolve it, you go 10 to exponent 1 is equal to 2x minus 3. Simplify it, add 10 and 3, divide it, and you get your solution. Okay, so this is straightforward. Just by connecting logarithms with exponents. Part C. Very much the same. The base is different only. So 5 to exponent 2 is equal to 3x plus 8. Find 5 squared value, subtract 8, 17 divided by 3, and you keep it. You don't change this to a decimal number. That's perfectly fine. Exact solution, 17 over 3. Part D, you have log to base x. Now, the base became a variable. Of 9 is equal to 2. So x to exponent 2 must be equal to 9. Find by square rooting both sides. So x is equal to positive or negative 3. But we know that the base of any logarithm has to be positive number. So this is why negative 3 is not part of solution. So the only answer here is 3, although algebraically we see that there are two possibilities, that the second option is not allowed. Okay, question E. Log to base 3 of x minus this number is equal that number minus that number. This is a constant value. So what we will do here is to rearrange that equation so we have one logarithm with variable x on one side, everything else on the other side. So this is why you see here the change. Log x is equal now to this. From the previous videos, if you remember, if you watch those, we were asked to simplify, express this sequence of logarithms in terms of one single logarithm. So the rule now of logarithm is being applied. So we can divide 18 by 2. The only way that this rule is applied because the logarithm base is the same. So combine 18 with 2 by dividing inside of log, and then because you add, you multiply. So now you have to simplify this expression. So 18 divided by 2 times 6. So either you divide 18 by 2 or divide it 6 by 2. It doesn't matter. The answer will be the same. So the next step, you see 54 on the right hand side, right? 9 times 6, 54, or 18 times 3, 54. So the base is the same. So the left hand side can be equal to the right hand side only if that value of x is equal to 54. There you go. So this is why this is the answer to that equation. Question F. Probably the most difficult so far. Why? Because we have two expressions containing the variable x. But we will do it anyway. We'll solve it. So, the first step is to combine these two logarithms on the left hand side into single logarithm, because we add, the base is the same, so this sum of logarithm is converted to a product. So this is why we have inside x minus 5 times x minus 2. So now this became a single logarithm expression. Convert this into exponential form. Get rid of logarithm, in other words. So, or expand this expression inside. It doesn't matter. It works both ways. So either you can keep it in factored form, x minus 5 times x minus 2, and the right hand side would be 2 squared, or you can expand it and equate it to 2 squared. So from this point on, normal logarithms. Now we're working with a quadratic equation. Combine this 10 constant value with 4 and set it equal to 0. So 2 squared is 4, and then by combining 10 and negative 4, you get 6. So solving quadratic equation. Quadratic equation by factoring, or you can use quadratic formula, it doesn't matter. So solve this. Find two possible values of x. That's the key here. So x is either 1 or 6. So this is the common mistake that we tend to make all the time by saying, well, I have two solutions, bingo, I'm done. Your job is always, 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 always to verify if this or that works. By inspection, 6 does work, because when you replace the value of x with 6, you will create positive number here and a positive number here. When you use 1, this gives you negative, because 1 minus 5 is less than 0, so is 1 minus 2 a negative. So this is why x is equal to 1 is not a solution. Very important for you to be aware of that. Always, always check. Before you submit the solution, say, let me verify that. If that doesn't work, if you find a number that doesn't work, reject it. I hope you have enjoyed this video. Any questions, post down below, and I see you next time. Thank you very much. Bye for now.